Yeah, so let's begin. Exercise 15C, I haven't tried. Let's go through 15B. Most of them are correct. Very good. The trick here is really just 2 steps. Step 1, differentiate. Something given y equals f of x, which will give you dy by dx equals f prime of x. Okay, whatever that derivative is. Step 2, typically they will ask you, what is the integral of, let's say, f prime of x dx? Then you'll realize, oh, it's just f of x plus c. Or if they have a limit, let's say a to b, you will just get rid of that plus c. Because if you sub in x equal to b and x equal to c, the plus c remains, but it will, after you substitute x equal to c, the plus c becomes a minus, so they will cancel away. Okay. Of course, it's not always so simple. Sometimes, instead of giving you the f prime directly, they will give you 2 times of f prime or half times of f prime. So it's your job to go and figure out what's the factor to multiply it by. Other times, they'll give you questions that are like integral of, let's say, half times of f prime of x. And then they add on something that you can integrate, like cosine x dx. Then in this case, how would you solve this? What you do is you split it up, split the integral up term by term. And you can factor out a half from the first guy, plus integral cosine x dx for the second guy. This first half requires part 1. Use part 1. This guy, on the other hand, you do it yourself. That's all there is to the type of questions that I will testing you on in this homework. Okay?
Okay.
I'm just using a funny notation f prime. F prime is a generic notation to represent all the derivatives. Okay, but anyways, let's go through your questions. Most of them are correct. Over here, you can simplify it as square root 4 times square root 5, which becomes simplifies down to 2 root 5. Both answers are acceptable. In case the question in the future you encounter a question where they ask you leave your answer in the form of a times square root b, where a and b have no common factors and b is a prime number. A does not divide into b and b is prime. This funny notation here means a is not a factor of b. Okay. They could ask something like this. So just be careful. Then you need to know that, oh, you can split it up as square root 4, square root 5, becomes 2 root 5. Okay, moving on. Yep, your trigo identities topic is very strong, very, very good. Okay, you got the identity.
No, it is not. It took me very long.
Took you very.
Yes.
Okay, so you must go and recap lah. Basic ideas are, if there's 2x and 1x, you gotta use double angle identity. And you only have how many options to choose from? 4 options to choose from. Sine 2a is 2 sine a cos a. And then there's 3 forms of the cosine. Cos square a minus sine square a. Substitute a cos square 1 minus sine square, you get 1 minus 2 sine square. Or the other case, substitute sine square 1 minus cos square, distribute the negative 2 cos square minus 1. It's all in the formula list. So don't worry about it. You don't need to memorize.
I hate trigo.
Yeah, you can't escape it if you are going into engineering. What else? If you see that here have a fraction, there don't have a fraction, well, it means that probably the 1 minus cos 2x can cancel away. Or if you work from right hand side to the left hand side, you need to introduce fractions. Another not so efficient way, but almost guaranteed to always work way is to break everything down into like break down into simpler pieces, right? What are the simpler pieces? Sine x and cosine x. Okay. But of course, that's not the most efficient way, but it is possible. If you're really, really struggling, convert everything into sine x and cosine x. Every expression can, almost every expression can be expressed in terms of sine x, cosine x. Okay.
Okay.
Yeah, okay, that's essentially it for trivial identities. But of course, you need to know how to apply. You got it right, so I'm not gonna go through.
Oh, by the way, is the thing that I highlighted, is it power reduction formula?
Yes.
Is it that?
Yes.
Okay.
You derived it on your own. Very good. I mean, I showed you before. But here, why do you call it power reduction? Because you start with cosine power 2, you become cosine power 1. So you can reduce the power. So you cannot integrate cosine square power 2 directly, but with this identity, now you can. Okay, now you can. How about if it's cosine power 3?
I mean, that's the later question.
That's a later question. Yes. That's a special identity involving, I think it's 4 sine cube or 4 cosine cube. I always cannot remember that one. But it's the triple angle identity. You got double angle. How about triple angle identity? That's the formula there. But the basic idea is you can derive it. They didn't ask you to derive it, but basically you can derive it on your own already. Cosine 3a can be split as cosine 2a plus 3a. What am I saying? 2a plus a. Then you use cosine a plus b formula, where a is 2a and b is a. I hope you're not confused. A here, b there. Then you expand. Okay. Yeah. You can imagine in the future, you're gonna be dealing with integral of cosine power 3, or power 4, or power 5, or power 6, or power anything you want. Then in that case, how would you integrate? First step, trigo identity. Okay. The questions here, they guide you part 1, part 2, part 3. But in the future, in uni, your prof is gonna just give you this. Okay, solve. That's it. Full stop. They won't guide you part 1, part 2, part 3. So you need to know. Trigo identities. In this case, power reduction. Basically, you only have one power reduction formula. It's this guy, power 2 become power 1. Then you gotta rewrite this in terms of power 2. So can you see that cosine power 5? How would you reduce the power? How can you link it to cosine square?
In cosine power 3x times cosine power 2x.
Hey, power 3, wow, still quite big.
Okay, can to cosine power 1x. Wait, cosine power 1x times 2 cosine power 2x.
Wait, no. Here it's cosine square times cosine square. Exponents. Yeah. Is it 2 times cos square?
No.
It's actually cos square whole thing square, right? So it's cosine x multiplied by, okay, I better put the brackets. Cosine x multiplied by cosine x power 4, right? 1 plus 4 is 5. Or in other words, square of a square, like this. Right or not? Yeah. What if it's power 7? What if it's power 8? What if it's power 9? What if power 10? Can you see the general pattern now? If I change this into 7, I plus 2 to the power, that means I have 2 more copies of cosine square. So I can introduce another cosine square there, which means this will become power 3, right? Can you see? 3 times 2 is 6. 6 plus 1, 7. Can you see that? Right, then from there, cosine square, you can substitute with whatever we found over there, and then you can continue to simplify it down. Yes, correct. Yeah, but then from there, you'll end up with like 1 plus cos 2a over 2 bracket power 3, which means that you'll still have a power 3 expression. you need to use binomial expansion to expand it. Okay, later if I have time, I go through one question. Maybe I go through how to solve integral of cosine power 5. Oh, don't want power 3, power 3. Okay, then after that, solve as usual. Okay, that's not in your syllabus, higher powers. It's in H2 math and uni. Moving on, you use the identity exactly like what I told you. We went through this already. Here, just be careful, tangent negative pi over 4. It's better to put a pair of brackets here. Okay, put a pair of brackets. So we are clear. Then this guy, tangent negative pi over 4. I hope you know by now it's negative tangent of pi over 4. Right? Because that's just the identity. You can factor out negative. Which other function relate among sine, cosine, and tangent? Which other function also has this ability to factor out the negative? Sort of factor.
Sine.
Yes, it's sine. Sine negative x equals to negative of sine x. How about cosine? Can you have cosine negative x equals to negative cosine x?
No.
No, it must be positive. Okay. Just remember that negative angle identities. Sine and tangent, they are called odd functions. And this is odd functions. Rotational symmetry of 2 about the origin. This guy is called even function. Now is not the appropriate time to talk about it because you haven't officially learned function notation. You can learn more about this after you learn about functions, which is a H2 math topic. Okay. So yeah, anyways, your decimal answer is okay. Exact value will be better for practice. Okay, moving on. This one, okay, very good. Yeah, so over here, you finally see an example where, oh, the derivative is not so easy. You need to use product rule and get this answer. Then you have to integrate both sides, which is on this side, the integral of two terms. Right, term on the left, term on the right. So you have to split it up, which is exactly what you did here. And then from there, you can make the x sine x the subject. Right? Why? Because that's what the question asked for. The question asked for integral x sine x, then you try to make integral x sine x the subject. That's what you're doing, right? Right?
Yeah.
Yes. Over here, can you tell me what is D in terms of C? D equals to what? Think about it. If you go from the line before to the line after, you have to multiply by
-1.
negative 1.
C.
Negative C, exactly. Yeah, so you could have just written minus C.
Oh, but you know,
okay.
I hate how to say, I hate the plus C thing.
Yeah,
like
you must.
I'm doing like the definite integral, or because I don't need the for later.
Yeah, as like definite indefinite integral without the numbers at the top and bottom, that one you must have a plus C.
Yeah.
Must remember. Okay, oops, sorry. Yeah. Okay, Ken, good. So now, yeah, your integral, this one is fine. This one, the interpretation, yes, total revenue for pi over 2 years is 1 unit, $1, whatever is the money they use. Whatever is the units they use. Okay, because here they say annual rate of revenue. It's not just the revenue, it's the rate of revenue. So it's like, you know how profit, pi for profit equals total revenue minus total cost. Pi is just a funny symbol to represent profit. Okay, this total revenue here is not what they're talking about. The annual rate of revenue, that is what they're talking about. It's a rate of the total R. Okay. They are not the same. You need to do a bit of work to get there, and that answer to get there is take the integral. Maybe in this case, the units would be dollars per unit years. dollars per year. So the graph of this annual rate of revenue function, the x sin x, well, I'm not sure how x sin x looks. Y equals x sin x. The y-axis here is something, but the units is dollars per year, and the x-axis is year. Let me just get a quick sketch of the graph of x sin x, and I'll draw it over here for you. Let's see, what is x sin x? Okay, so it looks something like this. Let me draw it nicely. It goes up, it goes down, it goes up, it goes down, it goes up, it goes down. And then you repeat on the left side, symmetrical. It goes up and it goes down and it goes up. This is x sin x. And it just keeps on increasing. Okay, interesting graph. But for practical, because this is a practical scenario, number of years cannot be negative, so we don't look at the left-hand side. Okay. Now, what are they asking? What are they asking when they ask you to integrate from 0 to pi over 2? You can interpret it like this. It's asking you to find the area under the curve here. This green one. This green one is integral from 0 to pi over 2 of the function. But let's think about it. How do you find area if it was a normal, let's say, rectangle? It will be length times breadth, right? Make sense?
Yeah.
It goes to area. Then the length has a unit, it's cm. The breadth has a unit, it's cm. So in cm times cm gives you cm squared, makes sense?
Okay.
But now we are generalizing the idea of an area. Here, instead of having units in terms of cm and cm, our units follow the x-axis and the y-axis variables. So that means that this area here is essentially dollar per year times year. Does that make sense?
Yeah.
So what do you get after dollar per year times year?
Yeah. $dollar.
Exactly. You're just left with dollars, which is why this is interpreted as the revenue. Revenue. Oops, where did my page go? Oh, very small. Let me write it a bit bigger. Because this is quite important. After you multiply, you get the revenue. This guy over here is the rate of revenue with respect to the number of years. With respect to time in year units. Okay, can? Area means you find not cm by cm anymore. It's the y-axis variable, the y variables units multiplied by the x variables units. So it's not usually it's cm times cm gives you cm square. Now it's dollar per year times year gives you dollars. Okay.
Okay.
Okay. Good. Moving on. Question 7 is done. Question 8. Careless mistake over here. This is the case where they talk about the triple angle identity. Yeah, 4 cos cube minus 3 cos x. Here, what you realize is minus 3 cos x. If you bring over, it should become a
Plus.
Careless mistake. All the way. Yeah. Just change the minus to a plus. Okay. But other than that, the answer is okay. Here is a plus, here is a plus, here is a plus. Yeah. Good. And also point to take note, luckily, sine pi over 3, you understand it is different from sine pi over 3. Can you see the difference? Can yeah, don't be confused, okay? Sine pi on top, the 3 is all the way below, versus pi over 3 inside the brackets of sine. Very different idea. Okay.
Mhm.
Okay, good. Can moving on. Question 9. Okay, yeah, very good. You break everything down into sines and cosines, and then you can get the answer. Okay, good. Sine over cosine extension. Yep. Here, part 2. Okay, here they are just asking you to differentiate. But they want you to give the final answer in this specific form, tangent square times secant square, because it will be useful for your part 3. I mean, you know, right? Trigo identities can be expressed in any form you want. So that's why they have to standardize it. Okay, tangent square, secant square, and they ask you to show. Here, all you need to do to differentiate tangent cube theta. Can you recognize that this is a composite function? Composite function means function of a function. The idea of the Russian dolls. You remember Russian dolls?
Mhm.
Okay, not very nice drawing. Or you can think of it as like layers of an onion. You can peel off layer by layer. Layer, like, okay, I don't draw too much. If not, it looks very bad. Onion, layers. Russian doll. You have smaller and smaller functions inside. Okay, I think you know that. Just like the onions, you as you peel and peel, it gets smaller and smaller. So over here, tangent cube theta is actually the same as tangent of theta bracket power 3. Now, can you see the two functions?
Okay.
What are the two functions? Y equals
Y equals
or if you want to express this in f of x notation, there's a f of x, there's a g of x,
x.
then this is f of g of x. What is
Okay.
f, what is g?
Like what do you mean tangent theta and then tangent square theta?
Did you mean cube?
I
Okay.
mean, yeah, tangent
So-
square theta times tangent.
No, that's multiplication of 2. This is not multiplication, by the way, this notation. Are you familiar with this?
I mean, gx is tangent theta, then f is square. Wait, does that make sense? I don't
Square,
know.
let's see. Sorry,
No,
I use x. I should use x. Sorry. So you're saying this is x squared. Let's see what happens.
no, it's x cubed. It's x cubed. My bad.
Okay. So if you replace the g of x with tangent of x, you get f of tangent of x. What does this notation mean? It means that everywhere where that was between the brackets of f, you treat it as the input of f. F is like a machine. It receives x as an input. It produces x squared as an output. It's like a machine. Okay, I draw a conveyor belt like this. This is a function. His name is called f. Let me give him a happy face. Okay, f. What does f do? F will take in x as an input. It goes in, do some processing. It spits out x squared. So you give it a 2, go in, you come out a 2 squared, 4. You fit in a 3 squared, you spit out a 9. Okay? That's the idea of a function. Does it make sense?
Okay.
Yeah. Okay, this is the basic notation, basic stuff you need to know. H2 math will go a bit more in depth. Okay, and uni math will go even more in depth. So anyways, so now that you have f of tangent of x, of course, if you can see, yellow color is now your tangent x, goes in here. What does the machine do to your input tangent x? Square it up. Exactly. So you get tangent square x. Is that correct? Is that what we want? Power 3?
No, tangent.
No. Yes, that's you corrected yourself just now already. Okay, so maybe I change this to power 3 to reflect the change. Okay, so now it's tangent power 3, x cubed, 2 cubed is 8, 3 cubed is 27. Okay, maybe I write the working. 2 cubed equals 8. Are you from is the function idea okay with you? Is the function idea okay with you? You need to repeat. What goes in will go up.
I think it looks
Okay, okay, good. Can. Okay, good. So now that you have you recognize the f of g of x, can you tell me who's outer and who's inner?
fx is outer, gx is inner.
Very good. Gx is inner. So what rule do you have to use?
you have to use chain rule. Is it chain rule?
Yes, you can. Another analogy for this idea is it's a bunch of chains connected together, the functions. You start with an x, then you go into a f, then you get f of x, then you pass it to a g, then you get g of x. So there's like a chain of functions. Oh, sort of like a food chain. You know what's a food chain, right?
Mm.
Like grass, and I forgot the arrow direction. My bio teacher is angry already. You get chicken, then you get a human. Okay. This is a food chain, just like a function. You start with x, you pass it to a f, you get f of x. Pass it to a g, you get g of x. Oh, sorry, you get g of f of x. Ooh. Okay, just like a food chain, but this is a chain of functions instead. So we have to use chain rule. How to use chain rule? 1/3 leave alone. Differentiate this guy. D outer times D inner, correct?
Yeah.
So what is the D outer?
The outer would be wow.
F is outer. So what's F?
3x squared.
Exactly. Yeah. So 3x squared. What do you do with the x? Do you look at 3? There's one more missing line. D outer something, then D inner. Keep the insides. What's the insides? Like the internal organ. The internal organ is over here, the inner. Oh, maybe I shouldn't say insides, I say inner. Keep the inner function. So instead of x here, it should be 3 something square. What's inside the pink brackets?
Tangent square.
Just tangent theta. Yeah. And then after you square the tangent theta, you get 3 tangent square. Yes. And multiply by d inner. So what's d inner?
D inner will be secant square x.
Over here, be careful, you're not x. D theta. So we have to adapt accordingly is theta. Okay? Can or not? Chain rule.
Yeah.
The key is to recognize your outer function, your inner function. The cube first, followed by the tangent. Okay, so power 3, you have to bring down, just use power rule. Bring down the old power, you get a 3, minus 1, you get the new power 2. But what's the base over here for the power 2? It must be the inner tangent theta. Okay? Okay, very good. Then let's simplify this. As a result, we get tangent square theta secant square theta, which is exactly the right hand side. Okay? Can? Good?
Yep.
Okay, Ken. Let me see the question again. What they say next. Okay, now part 3, hence evaluate this guy. Integral of tangent power 4. Let me just take a screenshot of the question. I'll paste it at the side. Do you think you can do this on your own? Do you need me to go through?
Scroll up a bit.
Go up.
Okay, I mean, so they want you to do integrate tangent theta to the power 4.
Yes.
And then
It's part.
or you would make it into part 1. You make it into integrate tangent square theta secant square theta minus secant square theta plus 1. Then you know what tangent square theta secant square theta, if you integrate it, you get 1/3 tangent cube theta. Then if you integrate negative secant theta, you get tangent theta. And if you integrate 1, you just get x. Then you box it.
Not x.
Wait.
What letter?
I mean theta.
Theta, yes. Okay. box,
And then-
square bracket.
Yeah, and then x will equal pi over 3 on the top, and then x equals 0 on the bottom.
Very good.
And then sub in, then calculate.
Yes. Try finding the exact value this time. Okay, let's do it together. Okay, tangent pi over 3 plus pi over 3. So there are two triangles you need to know. Let me draw it at the side. 1, 2, square root 3. This is 60 degrees, pi over 3. It started with an equilateral triangle. You chop it in half. So there must be pi over 6, 90 degrees. So this is, okay, from there you can find out your sine 30 degrees, which is over here, 30 degrees, and sine cosine tangent. Likewise for here, which is 60 degrees. What's the missing angle? What's in between 30 and 60?
45.
45 degrees. So that's when you need a isosceles triangle like this. 1 square root 2. Hopefully you can remember. Pi over 4 here, isosceles, so base angles must be same. This is also pi over 4, 90 degrees. Or 45 degrees. Sorry. I mean for pi over 4 radians, it will be 45 degrees. So from there, you can figure out sine cosine tangent of the 45 degrees. Okay, then tangent pi over 3 is the same as, how I remember it is like this. Pi over 3, I link it to 60 degrees. Pi over 6, I link it to 60 degrees. 30 degrees. Maybe I should write it like this. Okay, 6 linked to 3, 3 linked to 6. Then pi over 4, 4 linked to 45 degrees. Okay. Make sense? 3 go to 6, then 6 go to 3. Okay, a bit funny, huh? Then 4 is linked to 4. Okay, but anyways, how to solve this exact value? Tangent pi over 3, tangent 60 degrees. So that will be root 3, right? And don't forget, 1/3 in front, bracket, bracket, power 3. Minus way, tangent pi over 3, 60 degrees. So again, it's a root 3. Yeah, it's the same. It's the same. And then plus pi over 3. So here, well, you can't really simplify much. Maybe I'll combine into one huge fraction, all over 3. This is root 3 power 3. This is 3 root 3. This is plus pi. Guess you could, if you want to factor out root 3, you get root 3 square minus 3 plus pi. Oh, wait. What's root 3 square?
Just 3.
Then what's 3 minus 3?
0.
0. Oh, it's 0. Then that means root 3 times 0. Root 3 times 0 plus pi all over 3. So this is equal to 0 plus pi over 3, which is equal to pi over 3. Okay, good. Can. Interesting. Moving on. Any questions? Stop me if you have.
Okay.
Okay, I'll just move on. Okay, question 11 was very well done until this last step. How to continue? We want to solve for integral x e power 3x 0 to 1.
Split. Can
Split.
you see something repeating?
Let's split it. 1 over 9, there's an invisible pair of brackets. So you have to sort of distribute the 1 over 9. Okay? Does it make sense?
Yeah.
Okay, so
yeah.
split it and remember to distribute the 1 over 9. We end up with the following 3x e power 3x dx. Don't forget the dx. Minus sign 1 over 9 times integral e power 3x dx. Sorry, 0, 1. Forgot to put. Okay, interesting. Let's see something else that happens. Oh, there's a 3 factor in front of the x times e power 3x. Can you see the 3 there? Can you see the 3 there?
Yeah.
Factor out. So that means you're left with what?
X e to the power of 3x.
Yes. This case, the 3 and the 9 cancels away. You're left with 1 over 3. Is that correct? Yes? Can
Yeah.
now? Can now the 3 goes to the numerator? Okay, maybe I have my arrow better draw it nicely, point it towards the 1. Okay, so 1 times 3, then over 9, 1/3. Okay, very good. Can see or not? There's something repeating. Let me copy down the left-hand side first. 01 xe 3x dx. Let's see if I've been writing the same thing over and over. Anything repeating?
I mean, yeah, the first term.
What thing? First term. So how about we do something clever? We let capital I equals to our answer or the questions, what the question asks for. You can do that. It's a common trick, by the way. Let capital I equals to the answer. You realize what was the repeating thing? This part here, right? This part also equals to I. Right or not? So you're left with, yes, I equals to 1/3 times of I minus 1/9 times of that integral. Can we solve that integral? Maybe I put square bracket first.
Yeah.
Integrate e power 3x. What do you get?
Do you get e to the power of 3x divided? Wait, let me think. No, do you get e to the power of 3x? Wait, over 3?
Yes.
Is it? Yeah, okay.
Yes. Remember, when you're doing differentiation, it's always times. Integration is the reverse of differentiation, so you must reverse multiplication, which is divide. Okay, that's how you can memorize it. Well, the real reason is you differentiate this, you'll get e power 3x. Using factor out the 1/3, then you use chain rule on the e power 3x. I'll leave you to do it on your own. Differentiate to check, right? Check that the derivative of e power 3x over 3, sorry, my handwriting for 3, not very nice, equals to e power 3x. Okay, do you need a plus c here? Plus c? Need or not plus c?
No.
No, this is differentiation. Don't be confused. Okay, no plus c. Then close the square bracket, put in the limit 0, 1, x equals. Can? Good. So I equals 2/3 I, exactly. I think you know how to solve already. -1/9, this part just continue with square bracket. Sub in x equal to 1, you get e power 3 over 3, minus away e power 0 over 3. Right? Calculate a bit more. E power 3 leave alone. Don't use calculator. Over 3 minus away e power 0 is what?
1.
1/3. Okay, then you multiply out. So let's see. We get negative e power 3 over 9 times 3 is 27. Minus become a plus 1 over 27. Okay, good. 2/3 I remains. How to solve for I now?
Times 3 over 2.
Very good. Opposite, exactly. And then you got your answer. The rest is just algebra and simplification. Let's just do that. This is actually just one single fraction. What am I doing? Yeah, I can write it as 1 minus e power 3 like this. Much neater. Then I can multiply by that same thing. Sorry, my E handwriting very bad. I hope you can see. Okay. Then anything to cancel? Yes, 3 and 27, 1, 9. Okay, 2 times 9, 18. So over 18. And then 1 minus e power 3 at the top. Answer. If you want, you can replace the I back, sub I back with the original, which is x, what was it? Integral of xe 3 power x. Okay?
Okay.
Now, bonus question. Now that you have seen so many of the exact same questions where you differentiate first and then you try to find the integral, right? Do you think there is a direct, faster way that you could immediately find the answer starting with this guy? Directly, straight away, one line.
One line?
Yeah. Here you do part 1, part 2, part 3. Then you know, right? Integration is just the reverse of differentiation. So, okay, maybe not one line. What if you could directly work backwards? step by step by step, right? Correct or not? Differentiation is the reverse, sorry. The integration is the reverse of differentiation. Of course, differentiation also the reverse of integration. So that means if you start off with an integral, maybe it's possible for you to work backwards. Like differentiation, you work forwards, right? How about if you work backwards directly? Is it possible?
I mean, the way you say it, then yeah, I mean, I guess it's possible.
Yeah. Okay. Yeah. It is possible, but it requires specific observation, which is that the question over here. Let's look at question 11 now. It started off by giving you a 2x times e power 3x. So this is a product. So what rule do you have to use when you have a product multiplying? You have to use product rule, right? So product rule. That means you've used product rule to find dy by dx. Then if you want to reverse, that means you have to use the reverse product rule. Does it make sense?
Yeah.
Makes sense, huh? You have to reverse the product rule. But of course, it's not that simple. And this topic of reversing has a special name. I mean, okay, at least one interpretation of the reverse of a product rule is integration by parts. Okay, it's a very, very famous technique. It's in the syllabus of H2 Max, integration by parts. But for now, I won't go through because it's a bit complicated. You need to figure, but the main idea is there's a left factor and there's a right factor in your integral. Straight away, you can use integration by parts. Most of the time, it will work. But you have to pick a good choice of U and dv. Okay, I'll just stop there before I continue confusing you. Okay, yeah, so just know product rule, you can reverse directly. Here, they are guiding you, part 1, part 2, part 3. Okay, actually, this one also 2 lines only. Find dy by dx first of a very funny y equals. How do you know how do you even know that this y equals this guy is the correct thing to differentiate first? Imagine if the question started off with this integral and they didn't give you the y equals. How would you solve it? That's when it's that's when you need to use integration by parts. Okay?
Okay.
And yeah. Okay, good. This question is done. Then any other homework questions? No more. So I mean for 15B. How about 15C? Let's take a look at 15C. Let's see. 15C. Okay, so for 15C, I asked for the integral of these areas, right? I mean the area of those shaded regions, which requires definite integration. You never try. Never try. Okay, never mind. We go through now. Let's start with the simplest one, question 1A. You must try during class. Okay, we will discuss this together. Okay, should I make a new sheet? Yes, I should start a new sheet. Let me name the file first. Okay, question 1A, exercise 15C. Right, how do you find the area of this figure here? What is this function? This is y equals to 4 times square root x. Okay. Where are the point of intersections with the x-axis and y-axis? Maybe I should use singular point of intersection. Let's start with y-intercept. How do you find y-intercept?
Y-intercept when x is 0.
So that means that y equals to 4 times square root 0, which is 0. How about x-intercept? Other way around, so sub what?
Sub y equals 0.
Y equals 0. This time 0 equals 4 times square root x. Square root x equals to 0 divided by 4. Maybe I do one more line before I continue. Swap 4 root x on the left equals 0 on the right first. Oh, just swapping. Then after that, I bring the 4 over. Is that clear enough? Can I 0 over 4 is 0. So square root x equals to 0. Let's just write it down. Okay, just write it like this. Then how do you find x? Square both sides, right? So 0 square, which is 0. Okay, so just so happens that 0, 0 origin is the x and the y intercept. Clear?
Yeah.
Okay, so what is the shaded region? It is over here, which is bounded. Help me to remember this general picture over here. This is x-axis, there is y-axis, this is curvy line. Y equals f of x. I don't know what function it is. Okay, I have two vertical lines here. The left one is called x equal a. Second one is x equal to b. In order to find the area bounded below the curve, above the x-axis, to the left, from x equal to a, you have both right. So it's more like to the right. To the right of x equal to a and to the left of x equal to b, this region over here, can you see it? Below the function, above x-axis, to the right of x equal to a, the left boundary, and to the left of x equal to b, the right boundary. That area is equal to the definite integral from a to b of the function fx dx. Can you remember?
Yeah.
Okay, good. So for this special case, it just so happens that there is a there is a vertical line. Okay, let me erase this. There's a vertical line here, which is x equals to 0. It's just that this time, this curve part, it goes all the way down to hit the x-axis. So that's why your vertical left line here, you cannot see it. Okay, typically the question will ask you for area of this kind of shape. Okay, the one I'm highlighting in green. So you can clearly see, let's say x equal to 1, and then x equal to 4 in this case. But over here, it's actually starting from x equal to 0. Is that clear to you? The x equal to 0?
Okay.
Okay, then this other line, what is it again? X equals?
X equals 4.
Very good. Okay, so now that you have this formula over here, what is the area now? Area is equal to integral of, what's the function?
Yeah, 4 square root x.
Good, dx. Then what's the a and what's the b? A is the left one, b is the right one.
A
So
0.
0 and
4.
4 on top. 0 below, 4 on top. Okay, good. Now just integrate as per usual.
Okay.
Then this is the easy stuff, right? Setting up is the only thing I need you to learn from this. Setting, what we call a setup. Okay, the setup is the difficult part. Now it's just the standard stuff. X power, square root x is just x power half, so half plus 1 is 3 over 2. Add 1, you get 3 over 2, then divide by 3 over 2. Okay, square bracket, 0, 4. Sorry, x equals 0, x equals 4. So this becomes 4 times of, I can actually factor out the 1 over 3 over 2. Then sub in. Okay, simplifying this on a calculator, you can get 8 over 3, multiply by square bracket, sub in x equal to 4. So 4 power 3 over 2 minus 0 power 3 over 2. Can you calculate 4 power 3 over 2 without a calculator?
I mean, yeah.
4 cubed, then take a square root, right?
Oh,
But wait, maybe there's a smarter way. 4 is 2
I thought
squared,
this. Okay.
right? So now you have 2 to the power of 2 times 3 over 2. Oh, 2 cancels away. 2 power 3, which is 8. Right? Yes.
Yeah.
You must be very confident of exponents already. This one, It's the time when you must be confident of all of the things you have learned in AMAX. All the things I've been teaching you. Okay? Everything will come back and haunt you. Okay, good. So now you get 8 over 3 multiplied by 8 minus 0 power anything is? 0 power anything is?
0.
0 exactly. The only exception is 0 power 0. This is a math error. Okay. Or what they call indeterminate form. In the future, you'll learn about limits. Later, then worry about that. For now, just recognize it's indeterminate form. You will hear the very funny, sorry, don't say funny, it's the actual person's name. L'Hôpital's rule. Not L Hospital, it's L'Hôpital's rule. You'll learn more about it in the future. Okay, I don't talk about it. 8 minus 0 is 8, 8, 8, 64, 64 over 3, and that's your answer. Okay, unit square, if you really want to be precise, I don't need you to put the units. It's quite obvious. Can omit my instruction, can omit. Don't need to put unit square. Okay, unless you're doing econs, then it really matters. Money matters. The y-axis is dollar per minute, x-axis is minutes. Then you're finding area under the curve. Wow, then that one is actually money. So you must have a units dollar sign. Only in those application questions, then you need to put the units and it matters. But most of the time, they're asking for just the area, doesn't really matter. Clear? Okay, good. So now I need you to practice on your own. I need you to show me that you know how to do this. Okay, let's go on to a more complicated example, which is 1B. Okay, let's take a look. 1B. How? Okay, you know what? Let me just copy the graph so I can edit it more easily. This is y equals to 1 plus e power 1 minus x. Okay, this is question 1B. Let me see, I forgot to copy down something. The intervals, okay. Here's x equal to 1. There is the region they want you to find the area of. How to find?
Wait, why can't you just do like?
What was it? Oh, sorry, I wasn't looking at the screen. Good. Yeah, that's it. Exactly, done already. As simple as that. Okay. Don't even need to spell area, just A. That's it.
Wait,
yes.
Why do we need to find the x-axis? Or I mean the x-intercept and y-intercept.
Oh, that one. I just wanted you to recall your coordinate geometry, because later on the function will get a lot more complicated. You need to recall.
Oh no.
Yeah, they will have curves that intersect each other like this. Find the area over here.
Oh my gosh.
You need to find the point of intersection. So solve simultaneous equation, all the fun stuff. Okay, so let's just do for fun. What is this point? Sub in x equal to 0, right? What do you get for y? 1 plus e power 1 minus 0. This is just 1 plus e. Try to leave as an exact answer. So over here, label 1 plus e. Okay, try to give your answer in exact values. Okay, so let's just do that. So 1, integrate this guy. So you can split it up term by term. So in other words, you're integrating 1 dx from 0 to 1 plus e power 1 minus x dx from 0 to 1. So integrate straight away. You get x, square bracket, 0, 1 plus, integrate this one.
Oh, this is confusing. Okay, times -1.
Okay. How about this? Help me to remember it like this. E to the power of x, you integrate dx. You always get back e power x.
E power x.
Plus e, sorry. Then if it's e to the power of, let's say, 3x dx, you just copy the exact thing, but instead of multiplying, you divide by 3 plus c. But now let's say I have minus 3x instead. What do I do? Still copy down the same thing, negative 3x.
Divide by -3.
Divide by -3. Then if you want this part, you can simplify because the e power negative you can bring it down. So it's 1 over negative 3e power positive 3x. Exponential rules, okay? And what if you now upgrade to 8 minus 3x? You integrate this guy.
8
Still
minus
copy down the same thing, but
yeah,
you divide by
negative 3.
negative 3. Let me double check and see if this actually works out. I'll just ignore the c. Differentiate c, you get a 0, right?
Yeah.
Factor or negative 1/3, right? The negative sign goes to the left side, outside of the 3. Then you try to differentiate that e power 8 minus 3x. Well, how do you differentiate that guy? Copy. I love e power x. It's the easiest function to differentiate and integrate. Okay? My favorite function. Don't need to do any work. Okay, then after that, chain rule requires you to differentiate the 8 minus 3x. Okay? Which means you're left with negative 1/3 times e power whatever, multiply by the derivative of this guy. 8, you get 0. Minus 3x, you get minus 3. 0 minus 3, that's just a negative 3. Anything to cancel? Yes. Negative 3, positive, and negative 3. Negative 1/3 and negative 3. Okay. Minus becomes a plus. Okay, I better don't cancel it. Minus become a plus. 3 and 3 cancel away. Then you're just left with the original guy. Okay? Can? So now go back to this integral of 1 minus x. Hopefully you can see there's actually a negative 1 in front of x. So what's the integral?
The integral would be negative e to the power of 1 minus x.
Yeah, exactly. I'll divide by negative 1. Okay, then 0, 1. Of course, if you want, you could have just wrote down this entire thing straight away into one single line, then 0, 1. You could have went from here to there straight away. Perfectly fine. Quite doable, right? 1 becomes an x. This guy, copy the e power whatever, divide by the coefficient of x. Divide by negative 1, minus sign goes up. Square bracket 0, 1. Okay, sorry. I keep writing 0, 1, which is a wrong notation. It's supposed to be x equals 0, x equals 1, and use square brackets. Okay, then now we just sub in. No? So 1 minus e power 1 minus 1, bracket, minus away, 0 minus e power 1 minus 0. Make sense? Right? Okay, upper goes there, lower goes there. Okay, now calculate e power 1 minus 1, 1 minus 1 is 0, e power 0 is 1. So you're left with 1 minus 1. Okay, minus bracket 0 minus e power 1 minus 0 is e power 1. Simplify, what do you get?
0 minus. I mean, you just get e.
It's just a e. Wow, interesting. The area is e. The area is e. Wow. Not interesting. Okay, never mind. Area is e. So interesting. Okay, anyways, that is 1B. Let's try one more question. Oh, this one, trigo. Yes, try a trigo question. Let's go. So, how to solve this integral? Maybe draw the integral symbol first, and then standard procedure is copy down the function first. Dx. Don't forget. Then what's the lower upper limits?
Upper limit is why does it have like this stuff here?
Huh?
Like
what thing?
I'm just gonna ignore it. 3
Yeah,
pi
it's a
over
distraction.
2, and then 0. Then 1 plus sine x dx, which integrate 1 is just x. Then integrate sine x, it will just be negative cosine x. Square bracket x equal 3 pi over 2. Lower limit x equals 0. And calculator. The back part is 0 minus cosine 0.
And the front part is just 3 pi over 2 instead, right?
It's cosine 0, 1.
What do you think? Okay,
I
draw the
think
graph, cosine.
I
Like this,
think
down,
it
down,
is.
up, up.
Yeah.
Yes, it is. Okay, very good, very good, very good. It is a 1. So that means it's not always 0. You see 0, then 0. No. So this time is 0 minus 1, which is -1. Minus 1 become +1. Right? 3 pi over 2, let's leave in exact terms, don't use calculator. Wow, cosine 3 pi over 2.
3 times 180 divided by 2. 3 times 270. Oh, just 270. Here, 0.
Yes, good. Okay, hopefully you can get more used to radians instead of converting into degrees. Need to memorize a bit. The trick is, here is pi over 2. Then after that, it will just be multiples of pi over 2. 3 pi over 2 means jump 3 times. Right, start from here. 1, 2, 3. 270 is here. Can? I'll leave you to work on it on your own. 90, 180, 270, 360. Multiples of 90. Yeah. So 3 pi over 2 minus 1. Yep. That's it. You can always, plus 1. You can always combine into a single fraction, 3 pi plus 2 over 2. Also okay. Here, the y equal to 2 is just a distraction. It's a distraction. Don't worry about it. But let's make that, since you can understand the basics already, I don't think I need to go through all the rest. Go and practice on your own. This 2 here is to actually remind you that the maximum point over here is a 2. Make sense or not? Sin x always been in between what 2 values?
In between 2 values. Like 1
maximum and minimum. 1 and
1 and 0.
0. Oh, yo.
I mean 1 and minus 1.
-1. Remember, for sine and cosine always between -1 and 1. So if you plus 1 to the sin x, what happens? +1. That means that you end up with
0 and then 2. I mean the lower part 0, 2.
Yeah, lower bound is 0, upper bound is 2. Okay, +1. That's why they told you a 2 here. This is actually what's the coordinates here? Let's see. Sin x over here, up, down, down, up. So this must be a pi over 2. Pi over 2, 2. Challenge for you. Extend the question, make it more difficult. I'm going to draw some extra lines. Horizontal line like this. It's a tangent, so it's continue the horizontal. Drop down a vertical line at 90 degrees. So what shape do you see over here? 90. What shape? Hey, mic test. Is the audio connected?
Yeah.
What shape?
Rectangle. Wait, what
rectangle. Exactly. That's it. Rectangle. Not a trick question. It's just a simple question. Rectangle. Okay, you can see a rectangle. My drawing not so bad. Good. So now let's split it up in the following way. Here is region A. There is, you know what? I already labeled A. Maybe here is region A. There is region B. There is region C. What is B? B is this part here. C is that part there. Okay, find B plus C. Bonus. Find B plus C. How?
What the hell? I mean, oh wait, what am I even talking about?
That's
you just
plus only.
get the rectangle. You just get the rectangle, which was
Yes.
what? 3 pi over 2, which is just 3 pi. Wait, is it? Yeah, no, it's just 3 pi.
Correct.
Then
yeah, exactly.
3 pi minus 3 pi plus 2 divided by 2. As in
exactly. That's it. That's it. Yes. Correct. The answer you got.
I was like thinking like what the okay.
Another way you could do this is to go and integrate here, integrate there to try and find the area. But sometimes you have to be a bit tricky. You remember this kind of question from primary school? Like they have what was their favorite kind of question? You start with a square, you have a midpoint at all those 4 points, then you have a circle like this. Then for some reason, it gets chopped off into more circles like this, like this, like this. Then they shade in the leaf shape here. there, here, there. Ask you to find the area of this figure. Remember this type of question?
Sure.
How to find? You could use integration to help you. Like if you can imagine, this is x-axis, this is y-axis. Let me draw it nicely. Then this is the equation of a curve. Let's say y squared plus x squared equal to 1. Remember your coordinate geometry? Yes, must remember. Let's pretend the radius is 1. Okay, let's say this is 1. This is -1. You could make y the subject. So now it becomes 1 minus x squared and take a plus minus square root. What does plus minus refer to? Plus refers to the top half over here. Minus refers to the bottom half. So this blue one would be y equals negative square root 1 minus x squared. Then the top half would be y equals a positive. Okay, I'll just put a plus sign there. Okay, I don't need to put a plus sign there. Like this. Does it make sense?
Yeah.
Now you could find the area under the curve by doing more manipulations. For example, you could figure out what is the equation of this curve here. You realize that it's really just can you see that it's actually bigger? It's actually part of a circle over here. Can, right? So that means that you could find the equation of this circle. What is it? What's the center? Center is over here, which is 1 comma radius is 1, right? So 1 -1. So center is 1 comma 1. Radius is
1.
1. So that means equation is x minus 1 square plus y minus 1 square equals to 1 square. Do you still remember this?
Yeah.
Okay, good. Then I'm just gonna proceed. 1 minus x minus 1 bracket square. Then from there you can solve y minus 1. You get plus minus square root of that nonsense over on the right hand side. And then make y the subject. You get 1 plus minus square root of all that stuff. Blah 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 blah. Okay. Then you again, this is plus minus. So I think you can tell this is y equal to 1, y equal to 1, and plus minus. Plus is the on top one, top half of the purple circle. This guy is the bottom half. So that means this pink color, what this all means is that if I just redraw it in a nicer way without so much details. Blue bottom half is negative, okay. Top is the yellow one. Let me just clean this up to make it look nice. Okay, good enough. Like this, right? Then the pink color one, what is it? What's the equation of the pink color part? The pink color part is actually y equals 1 minus square root of 1 minus bracket x minus 1 bracket square. Square root the whole thing. So how do you find the shaded region of this piece of leaf over here, this orange part? One super long-winded way you could do it is to realize that isn't this region here? Isn't it really just start off with finding the area underneath this curve here? Can you see? Let me use blue color to represent the curve. Okay, but then you can subtract away the area of the other curve. Let me just change the diagram a little bit. So now I have the pink color curve this side.
Yeah.
And then you find the area under the curve bounded between two x values above the x-axis, which in this case is really just referring to this region here. I'll use broken lines to represent the other half of that curve. Broken lines to represent the other half of that curve. Right? Correct or not? You can take area under the blue minus area under the pink. That gives you the area in between the leaf. Does it make sense? So how would you do that? You already know the technique. It is just integral of the function, in this case, the blue color function is what? This blue one. It's the yellow highlight. So square root 1 minus x squared. Don't forget the dx. But from where to where? This is radius 1. 1, 1, 1, 1.
1 to 0.
1 to 0, so like this?
No.
Like this, 0 to 1?
Yeah.
Try to read from small to big. So 0 to 1. Or say lower 0, upper 1. On top 1, below 0. You must tell me. Don't just say 0, 1. Okay, it must be clear. Because if you swap it around, you're off by a negative sign, remember? So minus away, how about this one? Can you try and set up the integral? Tell me.
Integral 1 minus root. Oh, and then 1 minus bracket x minus 1 bracket close square. And then upper 1, lower 0, dx.
I hope that you are looking at the vertical lines x equals 0 and x equals to 1. By the way, there's a hidden x equals over here and there, here and there. For the sake of simplicity, we don't need you to write it. In the future, when you see this change into t, this better become t as well. T equals 0, t equals 1. Okay. And I hope that you are looking at this vertical line here, x equals 0, and this vertical line here, x equals 1. Likewise, all other guy. X equals is the vertical line equation, correct? Your coordinate geometry you can remember. Vertical line is x equals a, horizontal line is y equals k. Just use a different letter. Then straight line is y equals mx plus c. You know this, Hopefully. Good. So now you know how to set up. The question is, how do you solve this integral? The answer is H2 mathematics. H2 max. You will need to learn a technique called substitution. Okay, to simplify it, it involves chain rule. I will not be discussing this, so you will not encounter this kind of question. You can get the precise answer using very, very complicated techniques like this substitution method from H2 max. It's not really complicated once you get used to it. Yeah, but it's H2 max. I don't talk about it. But very funny, don't you find it very funny? Like a primary school student can find the area under area of this guy. Why would you need all these funny techniques for? Do you know how to do the primary school method to find the area? What I call the leaf. Can you find the area of a leaf? Length 1 square. You have a curve here, curve there, which are part of a circle. Then you have the leaf shape. How to find area of the leaf? Tell me. Hint for you, area of circle is pi r square.
You find, you do 1 over 4 times pi times 1 square. So just pi over 4 for the peak.
Half, why half? Where? Okay. Are you drawing on the diagram? I cannot see.
For this part. Like as in the whole thing.
Maybe you don't scribble. You draw slanted lines like this. Which part are you referring to? Wow, what arrow some more? Wait. You get what I'm saying? Like if how do you shade a diagram? Like
I swear it comes up differently from what I'm drawing. It's not me.
Oh, the diagram.
It's not me. It's legit not me. It's the. It's like you know what I mean. Like I'm drawing here, but then it shows up there.
Jumps. Oh, okay.
Yeah, it jumps. Yeah, it jumps.
Okay, hold on. Let me do something. Does this help? Okay, sorry. Try again.
Is it?
It helps. Yes. Okay. Right. So you're getting a quadrant. Okay. Correct. That's why you get a pi 1 square divided by 4, pi over 4. Good. Maybe let me do a few things. let me chop this diagram up. So it's easy to communicate. This region here, I'll call it A. This region here, I will call it B. Likewise, C and D. So what we just found was, what is it? A plus B plus C, correct?
Mm-hmm.
What we need is B plus C. How?
Oh, what the hell? This is actually hard.
What is D? Can you tell me what's the answer for D?
D is equal to A.
Huh? Correct. Okay, fine. I'll write it at the side, not the answer.
I mean,
Remember how
yeah.
just now, remember this question I just gave you, what is B plus C? How do you find B plus C? Do you need to find it step by step? No, you take big minus small, right?
Yeah.
Or
But
what I like to tell my students, shaded equals total minus unshaded. Okay, so let me just fill in the blank here. It was what? Length times breadth. Breadth is this, and minus away the answer we got just now, which is 3 pi plus 2 over 2. Simplify on your own. I'll leave it as an exercise. Yeah, how? Think. What shape do you see here? The total area. Wow, some primary school.
total area is just 1 times 1.
Total is 1 times 1. So what do you think is D? D is total minus away?
Total minus away this.
Exactly. The minus away the A plus B plus C, which we already found out is a pi over 4. So the answer is 1 minus
That's
pi
A,
over 4. That
which
is
is
for
A.
D, which is also
So you
A.
can take this minus this.
Yeah, exactly. Okay, so you just need to take A plus B plus C minus away. This is a very powerful technique, by the way, in integration. Chop it up into tiny pieces, label them A, B, C, D. Okay, and then you can use algebra to help you solve. Yeah, so anyways, A plus B plus C, you already know is pi over 4. Let me just write this down over here. And then minus away A, which is minus away 1 minus pi over 4. Distribute the negative sign now. So pi over 4 minus 1 plus pi over 4. This gives me, let's see, 2 pi over 4, which is pi over 2 minus 1. Answer, okay? Can?
Okay.
This is primary school math. Hey, you must remember. Okay, good. Now I'm sure you know already. Okay, then what happened? Let me think. What did I want to say? Right, so this is finding area of shaded region. With recap of primary school stuff. Basically, I need you to remember this: shaded equals total minus unshaded. Use this fact all the time. Don't just blindly find the integral all the way. Okay, good. What else do I need to talk about? I'll just go jump to more complicated examples now. Okay, 2A. Yeah, 2A got area under the curve. 2A is okay. I'll try 2B. Let's try 2B. If I can get my pen to respond. Ayo.
Lower limit 1, upper limit 2.
Haha. But something is off. Something is wrong. What's wrong?
What's wrong?
Just now I gave you this diagram over where is it? Wait. Hold on. I'm on the wrong worksheet. Sorry, give me a second. I need to add a page. I added to the wrong worksheet. Hold on. I want this guy, 15C. Then I want this guy over here. What was I doing? Let me see again. here. Just now I gave you the formula over here, right, for the area. This part here. Remember? This guy? What is so special is that this curve is floating somewhere. It's floating above the x-axis. However, the moment the curve goes below, the moment the curve goes below the x-axis, GG, it becomes negative. What I mean, if it's this case instead, where x-axis is here, but you have a curve like that, this is y equals f of x, you have x equals to, let's say, c, make it a bit different now. C, x equals to, I don't know, x equal to d. Then in this case, you have an area underneath the x-axis. This guy, negative area will become modulus of integral from c to d of fx dx. Maybe just to make you less confused, I'll use a different notation. Just now was f, now I change to g. Okay, different function.
Okay.
You have to take I haven't complete. You need to take a modulus. Why? Because this will become a negative value. Negative of what? Negative of the area. So you have to take a modulus to make sure it's positive. Can? Okay, can. So modulus. So repeat, what was the area again for this guy?
Modulus.
Modulus first.
Integral upper limit to lower limit 1. Good. 1 minus 2 over x.
And off with a
dx.
Dx, exactly. Okay, good. So let's just calculate the integral. So in this case, integrate 1, you get an x. 2 over x. Just do a bit of algebra at the side. 2x power negative 1, right?
Power negative 1.
And minus 2 can factor out. Integrate x power negative 1. What do you get?
Ln. Wait.
Correct.
Oh, yeah. Okay, yeah.
How about if you use power rule? Integrate x power negative 1, you add 1, get the new power, divide by the new power. You end up with a division by 0. No. Okay. Anyways, square bracket, lower limit x equal 1, upper limit x equals 2. Sub in, what do you get? Oh, don't forget the modulus. Sorry. I forgot the modulus. Must remember. Just 2 vertical lines. I'm trying to draw like this to emphasize on. Okay, sub in, what do you get? 2 minus 2 times ln of 2, bracket, minus away, 1 minus 1 times, sorry. The 2 is still there. 2 times ln of 1. Can you tell me what's the ln of 1? Here's the graph of logarithm x. Whatever base it is. This is 1, 0. This is y equal ln x. It's 0. Okay, very good. So in that case, you get 2 times 0, which is 0. 1 minus 0 is just a 1. So minus bracket 1. You don't need to put a bracket.
So 1 minus 2 ln of 2 ln times 2. So modulus.
2 minus 1 becomes 1 minus 2 ln 2. Type 1 minus 2 ln 2 in the calculator for me. What do you get? Okay, actually, I can show you. I think I have. Yeah, I can show you. Okay. 1 minus 2 ln. That's not ln. Ln is there. 2. Oh, it's negative. Sorry or not? Negative.
Modulus.
That's why you need the modulus. Then this one, it will become 2 ln 2 minus 1. You get what? Do you understand what I just did?
Yeah.
Right. Because you have to times negative 1. It's negative, you have to do times negative 1 to make it positive. And multiplying negative 1 to that value becomes 2 ln 2 minus 1. Okay? Right. Instead of the other way around, type it in 2 ln 2 minus 1. Like this. The positive value instead. Okay? Can?
Okay.
Clear? Good. Okay. Let's go back to presentation mode. Okay. 2 ln 2 minus 1. Answer. Very good. Moving on. Let's try more complicated examples. Let's see. What's a good example? Wow, this one. Very nice. Got both under the x-axis and above the x-axis. A mixture of both. My iPad just hanged on me. Give me a second.
0, ln 4, and 3.
Let me paste it somewhere over here. Okay, let's take a look at this question. Is it question 2? Yeah, it's still question 2. Okay, let's see. How? Wow, so complicated.
Modulus.
So technique I need to teach you here is to label the pieces with A and B. Okay, so area here will be now equal to A. I'll leave a gap plus B. Why did I leave a gap? Because I need a space. What do you think is A?
Modulus.
Modulus.
Upper limit ln 4, lower limit 0.
0, very good.
Then e to the power of half x minus 2.
The minus 2 is outside of the power. End off with a integral must always pair with a best friend, dx. Good. Okay, here they ask for ln 4, so we should try and find the exact value as much as we can. Like over here, like for example, 2 ln 2 minus 1, give the exact value. Then plus b, this one need modulus?
No need.
Don't need. Why? Because it's already
positive.
Already positive. More importantly, how do you know it's positive? Because with respect to the x-axis,
Above
it is
the axis.
above x-axis. Above then positive area. That's the thing you need to remember from this lesson. Okay, how do you integrate this?
Upper limit 3, lower limit ln 4. And then the rest is the same. As
exactly.
In yeah.
Yep, I get what you're saying. E power half x minus 2, the function, and then dx. Okay, so let's proceed. The rest is just integration, as per usual, right?
Yeah.
Now we can throw away the diagram already. But I strongly advise you to practice your geometry. What do you call it? Coordinate geometry and sketch the curve. Okay, so let's integrate e power half x. Can you tell me? You practice this one? Your e power not so good.
Yeah. So you copy down the same thing.
Copy.
And then you add a 2 at the front.
Divide by half.
Yeah.
Which is equivalent to times 2,
yeah.
which is what you said.
Yeah.
Right? Is that what you were thinking of?
Yeah.
Okay. Then integrate negative 2. Negative?
Minus 2x.
Good. Square bracket. X equals 0, x equals ln 4, right? Modulus outside. Good. Plus, let's just copy and paste this whole thing. But all you need to do is to change.
Yeah.
Change what?
3 and then ln 4.
Exactly. So just 3 on top, ln 4 below. Okay? Clear?
Yeah.
You have to repeat a lot of things. Please don't go and you see this one minus 2x, then become minus 4x. No. They are separated and they are protected by the modulus. Must evaluate separately. Okay? Even though it's repetitive. You can simplify it later. Okay, so let's just calculate this. So this is 2 times, okay, I need more space. Let me start off with an open bracket. 2e power half of ln 4 minus away 2 times ln 4, close the bracket, minus, open the bracket, sub in 2 times e power half times 0 is 0, minus 2 times 0 is 0. Okay, I mean, you can write down 2 times 0 and put a modulus close the sign. Save space, I need to bring it to the left. Sorry?
Okay, never mind. Wait.
Anything?
No, nothing.
Okay, can, good. So now next one, I'm going to sub in again. So now this is 2, okay, open bracket, 2 times e to the power of half times 3, minus away 2 times 3, close the bracket, minus away, open bracket. This time sub with the lower limit, 2e power half times ln 4, minus away 2 times ln 4. Here, notice that I did not try to simplify anything. Okay? Right? So, what you can do next is figure out whether this is positive or negative using a calculator.
Okay.
Right? You can use it. Okay, I'll show you. Fine. So save time. Let's just do it using a calculator because you have a calculator, then you can do this trick. Let's see, where is my e? Over here, to the power of 0.5 is half times ln 4. Okay, then minus away 2 times ln 4. And then minus away, okay, this one, I have to open a bracket. 2 times e to the power of 0. If you really cannot calculate in your head, don't worry, just use calculator. You can bring a calculator into exam hall. You get this guy, oh, negative. So what happens when you modulus a negative? It turns into positive, essentially multiplying -1, which means that after you multiply -1, this minus becomes a plus, this plus becomes a minus. Make sense? After you multiply negative. So that means that this will be equal to, I'll copy and paste with the power of an iPad. Without doing any calculation, I know this, using a calculator, I know this will become minus and a plus. Okay? Can?
Yeah.
So I open up the modulus. Can. The next half, copy paste. Okay, good. Notice how you see half ln 4. The trick here is half times ln 4. You can bring the half up, so it becomes ln 4 to the power of half. Bracket like this. Then what is 4 power half? Square root of 4, right? Which is ln 2. Oh, it's just a ln 2. But then this is actually e to the power of ln 2. Correct or not? E to the power.
So
e to the power.
I mean, it's just 4.
It's just no, it's just 2 times 4. That is the trick. Okay, so over here I'm gonna save some space by just writing down 2 times 2. Is that okay with you? I'll distribute the minus as well. Minus 2 times 2. Okay, then here is minus 2 ln 4. Okay, you know what? To save time, I'll just write down 4 straight away. Minus 4 plus 2 times. Of course, all this can be used done calculated using a calculator. Like this value here, right? So don't worry too much about it if you don't know the identity. Until they make the question tougher by introducing a A, a K, and a B, a C, then you have to worry. Instead of giving you ln 4, they give you ln K. Express your answer in terms of K. Then that's when you have to stress about your logarithm and the identities. The identity you need to remember here is ln of AB equals ln A plus ln B. Typically, you'll just be dealing with log base E because integration, differentiation, we only teach you e power x. Ln A over B will be ln A minus ln B, ln of m to the power of n. You can bring the power n down, it becomes a coefficient. Please do not minus 1 to the power. This is not differentiation. Warning. You don't go and, ln of m power n. So n times m power n minus 1 and ln. Correct or not? No. Then even worse, plus c. Because of what? Because I don't know, just memorize. Cannot be. Only integration, then you memorize, also need to memorize correctly. Only integrate indefinite integral, then you need a plus c. Please don't do that. We're using logarithm power rule, not the differentiation power rule. So there is no minus 1. And then after you bring down, it just disappears. Okay, the power. Okay, Ken, I'm sure you know this, Then log change of base. There's a change of base formula, right? Which is, let's say P and Q here. This will become, let's say I pick log base E, which is ln. I can go to ln P ln Q over ln Q. Okay? More generally, log base, I don't know, K. You are free to pick any base you like. All right. Okay. Very good. Okay. Other rules you should know. E to the ln of x equals x. X. Yes. Okay. No, it's ln. Ln of e to the x equals x. Can? These two? Can? Recap on logarithm and e power. This is essentially all you need. I mean, the power half, I'm sure you know, is square root, right? Don't need recap, right? Okay, let me know if you need. Let me know. Okay, moving on. Okay, e power 0. Okay, I write down 4 more rules for you. Okay, I scared you later don't know how to do the question. 1 power anything is 1. Okay, that's always like you can power anything. Anything power 0 is equals to 1. 0 power anything is equals to 0. Let me just swap it around to make it look nice. And the last one, last one is sorry. Last one is anything always has an invisible power 1. Makes sense, right? 5 is 5 power 1, 6 is 6 power 1, that kind of thing. The key thing over here is please do not replace anything with 0. Okay. If any equals to 0, that means that sometimes you get 0 power 0 equals 1, other times you get 0 power 0 equals 0. Huh? What? Sometimes 1, sometimes 0? Cannot be. So that's why we avoid any equals 0. In other words, okay, the main point I'm trying to say is i.e. 0 power 0 undefined. Okay? Good. Okay. A logarithm graph. Okay, quick recap on how the graph looks. This one must recap with the student every time when going through. If not, we'll forget. Logarithm looks like this. E power x looks like that. It goes up instead. Then if you draw them on the same graph, it looks like this. That's a y equals to x. Here is e power x. There is logarithm. Y equals e power x is like that. Y equals to ln x is like that. Here is 1, 0. There is 0, 1. They are reflections about the y equals x. Can? Can, okay. And vertical asymptote here. Horizontal asymptote there. Okay, that was a crash course recap on exponents. Moving back to this question, e power 0, anything power 0 is 1. So that means 2 times 1. So just 2 times 1. Minus away 2 times 0, just 0. Okay, good. And plus this one, 2e power 3 over 2. Okay, minus 2 times 3, 6. Minus away 2e power. Okay, this one we already calculated, right? So we can recycle the information 2 times 2. Of course, that's just minus 4. I'm distributing the minus already. Minus becomes a plus. 2 ln 4. Okay so far? Anything to cancel? Yes. These two cancel. Minus 2 ln 4 plus 2 ln 4. Minus 4 and minus 4 can cancel? Can or cannot?
Can make into minus 8.
Yes, you need to simplify, don't cancel them. So minus 4, there's a number, another number plus 2, there's a minus 6, there's a minus 4, and then here is a plus 2e power something. So let's just leave those light blue highlight alone. Focus on the yellow highlight. So if I'm too lazy, just calculator lah. Minus 4 plus 2 times 1, minus away 6 minus 4. Okay, hopefully you can learn to type quickly. Because you'll be doing a lot of this. A minus 0 can just ignore. And plus 2e power 3 over 2. If you really want to, oh right, I didn't show you the calculator. It's over here, minus 4 plus 2 times 1 minus 6 minus 4. Okay, back to the question. So now that's the answer. You can always present it nicely as 2 times square root e power 3, like this. You can put a 2 there. Did you know that for square root, you can omit the 2 here? Only for square root. Square root has a special VIP status, so they get to not write the 2 at the root. But if it's e power 5 over 7, it will become 7th root of e power 5, like this. Okay? Okay, the 7 must put there. Only 2 get a VIP status, don't need to put. Okay, this is equivalent to just square root e cubed minus 12. All right, can? Good. Exact answer. I want exact answer. In terms of e. Or in terms of pi. Exact answer. Give me all exact answer. This one I request. Okay, it will be good practice. Okay, back. Wow, this one question 3. Okay, this one must go through in class. Let's take a look at this question 3 here. So what I have over here is a very special function. Let's take a look. X equal y squared plus 2. Hey? Something weird. What happened?
But
Usually the graph is what? You start with what? Something equals mx plus c. What's the letter? Y equals mx plus c, right? Y is the subject when we are drawing our graph. Here there? Who's the subject?
X is the subject.
That is weird. Don't you find that weird?
Yeah.
Typically, y equals like x cubed minus 3 or something like that. Y is subject. Here we have x as a subject, which is weird. So what you need to realize is that there is a topic called inverse function that is technically not in your syllabus. But the key idea here is that if we have x equals y squared plus 2, can you make y the subject? Can you make y the subject? Of course you can. Y squared equals to x minus 2. Then from there, plus minus square root x minus 2. So what is plus minus x minus square root x minus 2? It's referring to the top half here. Sorry, I want to use a highlighter. The top half here and the bottom half over, top half here and the bottom half over there. Okay? Can? This is actually, hold on a second. How come this one not symmetrical? They should be a more symmetrical. They are intersection with, the intersection should be here 2, 0, and they should be symmetrical about this. Okay, so the curve, the graph a bit inaccurate lah. Oh, so yeah. And do you notice something? Let me show you let me see if I can find a video. Do you realize that this resembles a certain function you know? X equals y squared plus 2. What if I swap the x and y? What do you get? X becomes y. That means you get what? Y. Over here, y squared becomes x squared, and then plus 2. Okay? Y equals x squared plus 2. How does the graph look like? Usually. Can you sketch it? Y equals x plus 2. How does it look? Let me see. Oh. X squared plus 2, right?
Oh, wait, what am I doing?
So, how does it look?
Okay, wait. Sum.
Okay.
Why is it so hard? Sum x equals 0. No, cannot. X cannot equal 0 because you cannot.
Can. Over here. It's okay. Yeah, but actually, you're correct in that graph. It cannot be 0. But let's just ignore that. Let's just focus on this guy. You got a 0 squared plus 2, which is still good. And positive 1 coefficient. So
And y is 2x18.
good. X is wait. Wait, that's a bit weird. X equals to 2 square is 4, 4 plus 2 is 6.
I mean, when y is 4. Wait, when x is when x is 4, y is 18.
4 square, correct, yes.
Uh,
Then of course if it's negative 4,
negative 18.
negative 8. No, check again.
it's still 18. What?
Still
Then this looks then this looks like a modulus curve.
Not exactly, because it's an x
like-
square, right? So it is a what face? Positive coefficient. Positive is not more curvy, right? Happy face. So it actually looks more of something like the following. This, okay? This is y equals x squared plus 2. Coordinate geometry must go and revise again. Think of it like this. Y equals x squared is here at the bottom. Right or not? Y equals x squared plus 2, move 2 units up. Okay?
Okay.
Yeah, so anyways, y equals x squared plus 2. Let's focus on that. What do you notice if I do the following? Take a look. I'm going to do this. First, I rotate it 90 degrees like this. Rotate this way 90 degrees. Anti-clockwise. Right? Then the next step, I'm going to, okay, let me just draw a dramatic arrow like this. Wow. 90 degrees anti-clockwise. And then I'm going to do another dramatic arrow this time. Instead of rotating 90 degrees anti-clockwise, I'm going to reflect about the current vertical axis. So what's the current vertical axis? Vertical means what? Shoot, up, down, tree, like a tree. Up, down,
X.
So it's an x-axis. So rotate 180 degrees or reflect, or you can think of it as rotate 180 degrees. What do you get? The x remains. Right, the x after you rotate, it still looks like an x. Then the y goes to the other side. I'll just relabel as y. But what happens to your graph, more importantly? It turns into this way, can see? So let's label some of the points. Over here was x squared plus 2. So over here was what? 0, 2, right? Over here, if you rotate it, then what happens? This essentially sort of becomes a 2-unit length over here, right? The yellow highlight.
Yeah.
Then you reflect it, so it becomes a 2-unit length on the right side instead, right? Okay, then now I'm going to relabel x and y as y and x respectively. Okay, so that means now I get y here, x there, curve like this. And lo and behold, doesn't this look very familiar?
Yeah.
Oh, it's exactly the graph in the question. X equals y squared plus 2. This is now x equals y squared plus 2. We started with y equals x squared plus 2. Can you see what's happening?
Yeah.
When you interchange the x and the y, doing this funny dance move, rotate 90 degrees anti-clockwise, reflect about the current y-axis, will give you the resulting curve. Do you realize that this is equivalent to reflecting about the y-axis? Reflecting about y equal to x?
Wow.
Did you see that?
Reflecting about y equal to x.
Yes. Let me show you a video. I don't know if I shared this video with you already. Where is this guy? This is using y equals ln x and y equals x. I'll just start from the beginning. Okay, double speed. Okay, go. So that's y equals ln x, reflect about y equal to x, the broken line, you get y equals e power x. Can you see? That's called reflection about y equal to x. You see the x-axis and y-axis swap around. Oops, too fast.
Yeah.
You get it? So now this time it's just using a different function instead. The yellow pink color highlight, it becomes reflected on top. Let's see this part here. Can you see? The x is now on top there and the y is now over there on the other corner. Can?
Yeah.
Oh, yeah. So another way to visualize it. Let me see how I can let you see. Share my iPad screen first. Let me think. Yes. Okay. Camera. Okay. Hello. Can you? Oh, what's going on over here? This. Nope. Let me see. Where is the camera lens? It's over here. Oh, hello. Okay. Think of it like this. If I can just get it to point in the correct position. Let's say this is your this is the y-axis on my index finger and the thumb is your x-axis, right?
Okay. Yeah.
And you can rotate 90 degrees like this, okay? And then you rotate 180 degrees. 3D. Rotate 180 degrees this way about the thumb. Do you see that my y and x interchange?
Yeah.
So reverse like this. And rotate, and then 180 degrees. Okay, how do you do it more quickly? Remember the starting position was like this. Okay, if I can angle it properly. Now it became rotate like this.
You just flip the x with the y.
You're just rotating about the, look carefully. That's a diagonal satay line. You're rotating around the satay stick. Sorry, not line. Can you see? Of course,
okay.
Step by step will be 90 degrees first, then 180 degrees. This is called reflecting about y equals x. And it's a very important idea. It's called the inverse function. Okay, back to the iPad screen. Okay. So anyways, this is called the inverse of y equals to x squared plus 2. Provided that you restrict the values of x such that you don't end up with square root of negative numbers. Restrict the value of x to prevent square root negative numbers. If not, you'll get complex numbers. I don't want to deal with that. Right? Okay. So here, after you reflect this graph about y equals x, here's one way to solve this question is the following. Finding the area towards the left of this curve. Sorry, give me a second. My iPad is hanging every time. Okay, what was I saying? Yes. So sorry, give me a second. The iPad is not responding. Okay. And what was I saying? Okay, so finding the area to the left of this curve, right? That's the blue color area we are shading. Is actually it's more specifically is the area bounded by the y-axis, and this time instead of 2 vertical lines, it's 2 horizontal lines. So it's y equals to, can you see y equal to 2 and y equals -1? Maybe I should start from small to big. Can you see that? Y equal -1 and y equal to 2 at the bottom and at the top. And then the curve. And the curve. Okay, instead of below, it's to the left. Think of it like this. You have originally a graph like this. Now you have x-axis. You're dropping down towards the x-axis to find the area. Now it's the other way around. You have a curve like this. Then you have two horizontal lines. You're dropping down to find the area to the left of the curve. All right. You're sort of dropping down towards a particular axis. Right? Okay, good. Can. Now we are going to do the following. Just now I already discussed with you that it is really just a reflection, right? This graph is equivalent to a reflection of the curve, right? So a reflection about y equal x. So what this means is that if I can find what's known as the inverse function of this graph, I can instead change the problem from an area to the left of the curve, but bounded between y-axis and to the left of the curve, into the usual area under the curve, but above the x-axis. What do I mean? What I mean is I can redraw the curve. Okay, if I take this current graph like this, this is x equals y squared plus 2. I can reflect it about y equal to x. Okay, here's y equal to x. And as a result, I will end up with a quadratic curve like this, which was what we just found. It is y equals x squared plus 2. So finding the area from -1 to +2 is the same as finding the from y equals -1 to y equals +2 is equivalent to finding the area from x equals -1 to x equals to +2. Sorry, +2 should be over, more precisely, should be over here. Can you see that? You are, like, if this is y equals to x, you are reflecting it about this axis. Okay. So this -1, maybe if I use a bit of highlighting color, -1 here, +2 there. So that means -1 here. Okay, maybe I use a different color for the +2. I'll use green. Okay. So from the bottom, it was -1 and +2. So +2 is here. Okay, I better erase this. I better use a different color. Sorry. Let me change color. I don't want yellow. Let's try something else. I already use yellow. Let's try purple for -1 and green for +2. Is that okay? So let's do that. So purple for -1, so it's over here, right? Then green for +2 over there. That's after relabeling. Let's slowly work backwards. So if +2 is here, -1 will be there. If I reflect it, now that -1 will become there, the +2 will be there, right? Can see?
Yeah.
Reflecting, right? So that means now if you rotate 90 degrees anti-clockwise, just now you have to rotate 90 degrees clockwise to work backwards. So you end up with the green line over here and the purple line over there. Can you see that? Then the area is bounded between the curve, the two vertical lines, and a particular axis. Okay?
Okay.
Can yeah. So what this means now is, the question is equivalent. Finding the area of that region is really equivalent to finding the area of integrating this area. Sorry, how do I say it? It is equivalent to finding the area underneath this curve instead, y equals x squared plus 2, but bounded between -1 to +2. So we can just integrate x squared plus 2, but go from -1 to +2. Is that okay?
Yeah.
Oh, sorry, it's not dy, it's dx. Okay, so now let's see what is it. You get x cubed over 3 plus 2x, bracket, x equals -1, x equals to 2. Sub in, you get 2 cubed over 3 plus 2 times 2, bracket, minus away, -1 power 3 over 3 plus 2 times -1. What do you get at the end of the day? 8 over 3 plus 4, minus away, this is -1 over 3, -1 over 3 minus 2. Distribute, what do you get? 8 over 3 plus 4 plus 1 over 3 plus 2. 8 over 3 plus 1 over 3, you get 9 over 3, which is just 3, plus 4 plus 2, that's 9. Is there a faster way to do this? Yes. You can just look at it and interpret it as integrating with respect to y. Okay, let me just erase this. I go to. Does it make sense?
Yeah.
So what you can do is another way. Straight away jump to integrate with respect to y instead. So here, capital A area is the integral of this function. You have x as the subject, right? So it's x here, then dy. But you want to replace the x with y squared plus 2 dy. Here, the letter change into what letter? What is it? D.
Dx.
No. Currently, what? No, I'm like, what letter do you see here?
Dy.
Dy. This dy means that y is the variable of the integral. So if you have variable, what do you put over here at the top and the bottom? It must be y equals something, y equals something. For the previous one, when it was dx, you put x equals something, x equals something. Is that clear?
That's y equals something y.
Correct. But you can interpret it immediately from this kind of graph. It is the area from -1 to +2. The small y to the big y. But this time, instead of vertical line, it's horizontal line. Okay? And what is x? Of course, you can just immediately replace with the function they gave you, y squared plus 2. Okay? So y equals -1, y equals +2. And then you realize, doesn't it look exactly the same as the original one?
Yeah.
You're just replacing x with y. So at the end of the day, the working is exactly the same. It's just everything replaced with y. Instead of x cubed over 3 plus 2x, it becomes y cubed over 3 plus 2y. Sub in y with upper and lower limit. Okay? Can?
Yeah.
Good. Okay, 10:07 already. Let me see. Any difficult questions? Okay, the rest of the questions, right? They require you like 4, 5. They require you to draw the graph. Okay. You really need to draw the curve. Can which question is difficult? Let me see. This one. Okay, sometimes they'll ask you to show that a certain inequality is true. The question was, it got cut off. Show that this inequality is true. For the graph of y equals to x minus 1 over x squared. They will give you the graph. Then they'll ask you to show that this inequality is true. Now, this question requires you to examine the diagram and realize that, this region R here, the area, is actually just bounded between this piece here. I'll use blue color to shade it in, versus that piece there. I'll shade it in red. Can you see? The blue color is actually a triangle, and the red color is a rectangle. So the curve is somewhere in between. Okay? Make sense? So what you're supposed to do is just state that the area of the triangle ABC is less than the exact integral, which is less than the area of rectangle ABC. Okay. But labeling of the coordinates, this one, they're just showing you the working coordinate geometry stuff. The integration part is over here. The value of that integral gives the area of the region R enclosed by the curve, the line x equal to 2, and the x-axis. Okay? Then you can conclude straight away from the diagram. Therefore, area of triangle ABC less than this exact area R, which is less than area of rectangle ABCD, BCAD. Okay, then how do you find area of a triangle? Half times base times height. How do you find area of a rectangle? Length times breadth. Okay, then from there, you just need to do a calculation of the area of triangle and area of rectangle. That's it. Okay, the tricky part is you need to draw the diagram and you need to be able to see which triangle and which rectangle are they referring to. Okay, and yeah. Okay, then another kind of question they will test you on. Okay, I go through this. Let me think, which is a good question to go through. You have time or not? Can I go through one more question?
Yeah, sure.
Okay, let's take a look at question 9. Am I going from 0 to 100 too fast? I don't know. I think it's you can handle. Let's take a look at this one. Exercise 15D. Question 9. Let's take a look at this question. We have a y equals to 2 over x squared. It's this guy over here, a curve. 2 over x squared will look something like this. It's actually like a volcano shape. It doesn't cut x-axis because it's over x squared. You can never divide by 0. So that means it will just become horizontal like this. Okay, as x gets bigger and bigger, this 2 over x squared will get 2 over 10, 2 over 100, 2 over 1,000, 2 over a bigger and bigger number. It will become a smaller and smaller fraction. So small, but it will never be exactly equal to 0. Is that clear?
Yeah.
Okay, yeah. Well, I can draw a smooth curve. Okay, not important. Anyways, that is y equal 2 over x squared. How about the other straight lines or curves? There's a y equal 3 over 2x plus half. So positive gradient and y-intercept is half. So y-intercept here, half. Positive gradient 3 over 2. And then you have y equal to half, which is horizontal line. Okay. The question, let's see. The figure shows part of the curve y equal 2 over x squared. The other half is on the left, not relevant to the area. The straight line y equals 3 over 2x plus half cuts the y-axis at 0, half. So over here, 0, half. And the curve B at 1, 2. Lucky for you, they already calculate the point of intersection for you. You don't need to do it again. Otherwise, you have to solve this equation 1, equation 2, 1 equals to 2. Blah, 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 blah. You eventually get x equal to 1, then blah, 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 you get y equal to 2. Then conclude B is 1, 2. Thankfully, the question didn't request for you to do it. They gave it to you already. Okay, then the line y equal to half cuts the curve at C at 2, half. So likewise over here, 2, half. Okay, this one is just a y equal to half, not so bad to calculate on your own. Sub y equal to half to the 2 over x squared, solve for x. Then after that, calculate the area of the shaded region ABC. Oh, by the way, point C here, the x coordinate, can it be negative?
X coordinate, no.
No, right? It's a positive 2. Why? Because it's on the right of the y-axis. So sometimes the diagram you have to take it literally. At least for AMAX, the practice questions, the homework questions I'll be assigning you. C is on the right of the y-axis, means it should be positive x coordinate. Okay, can. Then calculate the area of the shaded region ABC. How? What have we learned so far? Area, if you got something like x equal to A to B, area like this, very simple.
Yeah.
This is fx.
Yeah.
Let's integrate A to B. If it's below, let me just do a quick sketch again. If it is below, you need modulus C, D. Integrate C to D, F. Okay, I don't use F, I use G. Gx dx, but make sure you got the modulus. This is y equal g of x. My y and g looks the same. I'm so sorry. Try to make it look different. Hope y'all not confused. Then now what we have? What do we have? Funny curve, right? Is it just a single fx? Is it just a single g of x that has an area under the curve?
No.
No. What we should do? You should think of a roller coaster or maybe some guy on a skateboard.
Okay.
What is he doing? He is going up, and then oh no, he has to drop down like this, bend and then drop down like this. Then along the way, he starts leaking something out. I don't know what thing. Drop down like this. Drop down. Okay.
Okay.
That's how you interpret the area under a curve. All right, you start from along the graph, the f of x, and then you consider the area that's beneath it. Likewise, over here, there's a, for the other half, this other curve, there's areas underneath the curve. Can imagine this scenario? Okay, good. So now let's take a look. How many functions are there in this curve? Is it just one single function?
No.
On top? No, it's a straight line followed by a curve. Two separate functions. Whenever you have that, what happens over here is it becomes a very sharp point. Can you see it's a very sharp point?
Yeah.
Just like y equals to modulus x. I remember the graph of y equal modulus x. It's actually made up of two pieces, right? This is y equal negative x. There's a y equal positive x. They join together. That's why they have a sharp point. Does that make sense? The sharp point idea, very important idea. Whenever you have a sharp point, what are you supposed to do? Identify the sharp point. It's point B. Drop a vertical line down. Okay. Then vertical line is has an equation, right? Can you tell me what's the equation? What's the equation? B is 1, 2.
Y.
X equals?
X equal 1. X equal 1.
So final answer, x equals 1. Okay, good. Then how to find the area under the curve? Oh, I know. Just find the left x-axis, left vertical line, right vertical line. So how about this one and this one? So it means
lower
x
limit 0. Right? Lower limit 0.
So does it mean
upper limit 1?
Area equals integral 0 to 1. Then the function, what is it?
The function will it be the straight line? It will be y
maybe
over 2x plus half.
3 over 2x, you mean?
Yeah, 3 over 2x plus half. Then
okay, dx.
Then
and plus
the
you got another half. You need two vertical lines, right? So there's a vertical line here, it's x equal to 1 again, but what's the next vertical line?
Upper limit 2, then lower limit 1.
Over here, right? Okay, maybe I use broken line again. Start with the end point and then drop a vertical line down. There's the vertical line, then label x equals to 2, underline. Can you see how I'm leading on purpose? Can you see that there's a mistake already? From 1 to 2, right? Then you have the other curve, which is what? The blue one. Okay, maybe I'll highlight in light blue. Light blue here.
X squared.
Yellow is this guy. 2 over x squared, exactly, good. Then don't forget the dx, right? Can Okay, good. Now, problem, is this the area?
No.
Why? No, man, I thought just integrate lah. You see left, right, then integrate. Left, right, integrate.
You need to minus.
Very good. Yes, because you see, this curve is bound by two vertical lines and what's the last missing line? 1, 2, 3. Where's the fourth line?
X-axis.
The x-axis. So that means that over here, what we just found is actually the region over, if I can just shade it. Let me just use letters to represent it. Here's P, here is Q, here is R, here is S. Can you see that P is this triangle shape, right angled triangle? This Q is like a rectangle. Not like it is a rectangle. This R is another rectangle, and this S is a curvy triangle, so it's not really a triangle. And what we just found was P plus Q and S plus R. Correct?
Mm-hmm.
Let me just label it. This is the A on the left-hand side. I better don't write A. I write area, clearer.
-1.
S plus R. Yes, you have to take away something, which is the area of Q plus R, correct? The rectangle. And what's the area of the rectangle again?
-1.
Yes, correct. Because it's length times breadth 2 times half, which is a 1. So -1. Okay. In this case, the area was 2 times a half, which is equals to 1. So as a result, the total area is really just this minus 1. This guy is rectangle Q plus R. Make sense? P plus Q plus S plus R minus away Q plus R bracket. Okay, so minus Q minus R. I'll leave you to calculate this on your own. Okay. The difficult part, the only new thing you're learning now is how do you translate from coordinate, how to use your coordinate geometry skills to identify vertical lines. Then you can identify your lower and upper limit. Then you must also identify, using the skateboard idea, who is your function above the curve, above the area. In this case, the yellow color curve is above this area. So you use the yellow color curve, which happens to be, if you look at the highlight, 3 over 2x plus half. And then for the other guy, same thing. The roller, the skateboarder or whoever it is, goes down this curve, this blue color curve, which is actually a part of 2 over x squared. That's why you use 2 over x squared. Then the limit, same thing, 2 vertical lines. Right? And then you realize there's a mistake because it's actually finding the whole thing bounded between the yellow and blue curve, 2 vertical lines, and a horizontal line, which is the x-axis. Too much. We don't need Q and R, so we have to minus away. And this one using just Sec 2 mensuration topic, area of a rectangle, length times breadth. Even primary school students know this. So you just need to minus away that area. Okay, total shaded area equals to total minus unshaded. Okay, maybe I write it down again. Right, shaded equals to total. The total is over here to here, then minus away this part here, the unshaded. This one very, very important idea. Although it's quite simple, but it's quite important. Shaded equals total minus unshaded. We clear.
Yeah.
Can good. And just be careful, if you have areas that are under the x-axis, it will be negative. Make sure to put a modulus. Okay, just some more tips. Below x-axis regions, or what we call, this is a formal word to use, regions. You will have to put modulus or absolute value. What else? If it is this kind of diagram, this is y equals to, let's say, P and y equal to Q. Then you have the area here. This is x equals f of y. Notice how I swap the x and y around. Usually it's y equal f of x. Right? If it's this kind of curve, you want to find the area over there, this region here, what you're supposed to do, integrate the f of y with respect to y from y equals to small to y equals to big. You know what? Instead of using notation, I'll just say small, big. Y equals to small to y equals to big. And of course, small is below, big is above, because that's how the y-axis works, right? Okay, so I'll just put it here. Small, big. There is one more case, which is when it goes to the left of the y-axis. Okay, then this is just like the case where we are dealing with areas that are below x-axis. We have to take a modulus. So let me just give you an example. Like say, I don't know, Let me think, how would this graph look? Let me visualize first. Let me think. If I want to curve over here, then I would have to rotate 90 around. So this would be negative x squared minus 1. If I solve for x, I will get y plus 1 multiplied by a negative, take a square root. So x equals square root minus y minus 1. Whoa, that is rather confusing. Never mind. I'll just give it to you in general, but you are unlikely to encounter this situation. If you have a curve like, say, this guy, still x equals f of y, but this time you are to the left of the y-axis. Okay? Still y equals big, y equals small. You still use the same formula, but you just put on an extra modular sign. Okay? Oops. You just use the same formula, but with modulus. Okay?
Okay.
Very good. Then the rest is all application. You must remember your coordinate geometry to find area. Actually, still got one more concept I haven't go through. I'll explain in more detail next week. But the main idea is this graph. Let me just write down points that we have learned so far. This is number 1. Yeah, very messy. This is number 1. Area under a curve is this formula. This is number 2. Area below a curve, you need to put modulus. Then point number 3. To find shaded area, it's just total area minus unshaded. Okay, this is a repeat. Point number 4 is if you have areas that are, you have functions that are that have x as a subject, then everything in terms of y on the right side, you use this formula instead. Take the function on the right hand side, integrate this time with respect to dy, but then your y value you pick small to big, provided that the area is to the right of the y-axis, similar to how it was above the x-axis. Then now, number 5, if we move the area to be towards the left of the y-axis, which is equivalent to being below the x-axis, you can imagine, right, if you reflect this about y equal to x, you end up with something like this and like this, right? So this is equivalent to being to finding an area that is below x-axis. The area will become negative. More like the definite integral will become negative. So you need to take the modulus to make sure it's positive. Okay? Now, point number 6, let me just quickly bring this up. Okay, this one is repetition. Refer to above. Point number 6, let me just quickly bring this up before I go, in case you encounter a question like this. If you find 2 curves that intersect like this, say inside at this point, then you have the area in between. What you do to find this area is, let me label this as blue color. The black color is y equal g of x. Nah, I prefer the other way around, just for fun. F on top and g below. Then the area, the red color area here will actually be if they intersect at, let's say, A to B. The x coordinate of those points. Let's say this is A and A comma question mark. And this point is capital B, B comma question mark, whatever is the y coordinate. The area will just be integral of top minus bottom. Hey, don't want. Let me go back to the original. Sorry. You hear F there. I prefer my top function to be F. There's no difference. It's just a notation. Okay, can you see that the blue color curve is above and the black color curve is below? Maybe it's smarter if I label my y equal g of x like this, so I can clearly see fx is above, gx is below. Oh, you always take the top curve minus the bottom curve in terms of x. Then you integrate from, okay, guess, what do you think? From where to where?
From B, from
On top, below, which one is which one? Upper, lower limit, which is which?
B, A, B, I mean, B upper, A lower.
Exactly, very good. Okay, no time to explain this. You can quickly try with a few examples. Like, I don't know, maybe, oh, careful. Let's say x plus 1 like this, it goes down. Then let's say you have y equals to x. It will look something like this, intersect. Then there's a region here. Find the area. Yeah. The answer is very simple. It's just integrate. Okay, find the point of intersection first. So that's when you need x equals ln x plus 1. Solving, you get e power x equals x plus 1. And this is a bit difficult to solve. You cannot solve this. Not a good question. If you are able to solve this, what you are supposed to do next is, let's just say that this is a value of p. This intersection here is 0, 0, 0. So x coordinate is 0. The area will simply be 0 to p of the top function minus away the bottom function dx. Okay? Yeah. That's it. The reason is you can integrate term by term. If you integrate the first guy, you get this whole area, right? If you integrate the second guy, you get this whole area. If you put a minus in between them, you're just straight away taking total area minus unshaded area to give you the shaded area. Make sense? Total minus unshaded gives you the shaded. This triangle is the unshaded area. Okay.
Yeah.
This is like f of x. That guy is like g of x. Maybe I should label it with a different color. I'll label this as pink color, g of x. This guy is g of x. Okay. Area equals top minus bottom. Integrate from left to right. Done. Okay, that's all for today. I will assign you homework from the exercise 15C and 15D. Then you go and do some of the basic examples from 15B as well. Okay. That's all for today. Bye-bye. Let me know if you got any questions.
I will always let you know.
Go ahead.
I think I messaged you like 5 times for just like one.
Yeah, no worries. Just go ahead and ask.
Okay. Thank you.
Thank you.
Oh, by the way, I need
yes.
you, right? Yeah.
Yes.
Yeah. So you just